and thank everyone who took the time to email us their questions. We've included as many as we could here in this presentation, but there were still plenty of great questions we will not be covering today. The purpose of today's call is to go over frequently asked questions and troubleshooting for the Comlink specifically. We will not be getting into detailed installation guide of the OmniShield app at this time, but don't worry, that is something we will be working on and releasing in conjunction with the new version of the app we are working on. So let's get started. So what's in the box? Each unit comes with the Comlink itself, a short Ethernet cord, a power adapter, and most importantly, the owner's manual. The whole reason I've included this slide is to point out that almost all of the information you need to be an expert on this product can be found in the owner's manual. In fact, a lot of the information I'm covering with you today was copied directly from the manual and pasted into this presentation. So I challenge you to read all the product manuals cover to cover, because nothing is quite as embarrassing as a customer knowing more about your products than you do. I'm just saying. Let's get started by getting to know the different LED icons on the face of the unit. The green power icon is located on the far left. The power icon will remain solid green when the unit is powered on and connected to the internet. To the right of the power icon, we have the warning light, also known as the caution symbol. This icon will flash rapidly red when a sensor on the network has detected high levels of CO gas. This will be accompanied by the 4-beep sounding of the horn, and a text message will be sent. The same warning icon will be solid yellow, and the horn will emit a tone if a water sensor on the network comes into contact with water. Next to the warning icon, we have the wireless radio icon. This will flash blue to indicate that the Comlink's bind mode is open and ready to accept sensors. The wireless radio icon will automatically stop flashing, and bind mode will close 10 minutes after the last sensor has been added to the network, or immediately after the Comlink's button has been pressed. The fire warning light will stay on continuously if a sensor on the wireless network detects fire. The horn will also chirp with a 3-tone pattern, and a text message will be sent. This slide is probably the reason most of you are on this call today. This combination of the yellow warning icon and blue radio icon will flash alternately if internet service is not found or has temporarily been lost. For those of you who got on this call specifically for tips how to combat this, don't worry, we will get to that shortly. It's understandable if you've never noticed these tiny LEDs on the back side of a Comlink before, but these little lights actually give you much needed insight. The connection LED on the right will light up solid green when there is an Ethernet cord attaching the Comm to a router. This green light does not mean there is internet flowing, but it at least tells you that the physical connection is good. The activity light on the left side of the port will flash orange to indicate data is being transmitted. If you run into a scenario where neither light is on, then you likely have a bad Ethernet cord or the router's Ethernet ports are not working. Assuming, of course, that you didn't forget to plug in the Comlink to the power supply. Just don't be that guy. Don't forget that we carry 2 models of the Comlink now. There is a Wi-Fi capable unit, which is the same unit we've always carried since the launch of the Comlink, and more recently we've introduced an Ethernet only model Comlink to combat the supply chain issues we're having surrounding the Wi-Fi chips. Ethernet installs are easier and generally more reliable, but there are instances where you might have to or want to install a Comlink wirelessly. Just make sure you have the correct version prior to going to your install, and it's always a good idea to have at least one of each with you when you're doing these installs. So what's the difference, and how do we know what we have? Let's take a look at that. Ethernet only Comlink should arrive in a box with a label indicating Ethernet only. However, humans are not perfect, and it's possible you might get a box without the proper labeling on it. Here's the only surefire way of knowing if a Comlink is Wi-Fi compatible. First, remove the Ethernet cord if one is plugged in. Next, plug the Comlink into power only. If the comlink is a Wi-Fi capable model, it will broadcast its own Wi-Fi signal. Now you can use your phone to view all the available Wi-Fi networks in the area. If you see one labeled Comm 1234 with the numbers being the actual serial number of the unit, then it's definitely a Wi-Fi capable model. If you do not see a Wi-Fi that matches the comlink serial number that you plugged in, then it's definitely Ethernet only. I've had people ask me if a Wi-Fi capable comlink that they purchased can be used for an Ethernet hookup, and the answer is absolutely. Comlinks that are Wi-Fi capable can connect with either Wi-Fi or Ethernet. However, comlinks that are Ethernet only are exactly that, meaning there is no Wi-Fi chip on board and you can only hook them up with Ethernet. This is by far the question I get asked the most frequently. Why do some units not update in the app? Well, assuming the customer's internet is working and the units are bound properly, the reason for some units not updating the app comes down to two things. The distance between the comlink and the sensor is too far to communicate directly, or there could be something between the two causing interference for those updates. Inevitably, the next sentence out of everyone's mouth is that they thought that the range was 200 feet, and they're only X feet away in the next room. So why is this happening? The range listed in the manual is referring to line of sight open field testing. Each home you visit will be drastically different, and I'm sure none of them will have clear line of sight from each sensor to the comlink. There are also variables that can introduce interference when dealing with RF or radio frequency, certain building materials, appliances, and other wireless devices, just to name a few. Another frequent topic is batteries displaying blank in the app, even if they're updating. A blank battery in the app does not necessarily mean the battery is dead. If the battery is actually low, the sensor will audibly chirp and be accompanied by the blink of a red warning icon every 32 seconds. The reason a blank battery can appear in the app is because the comlink only received a partial update from that sensor. Just like getting no update at all, this can be attributed to distance and/or interference. We're actively working on a solution for the next version of the app that will not display the battery as blank in this scenario. I get this one a lot too. I was told every sensor is a repeater. Why aren't the other sensors repeating the updates so the information makes it to the comlink? The answer is pretty simple. To conserve battery. If we used every sensor as a repeater for each unit's individual update data, all of the batteries would drain exponentially faster. However, in the event of a smoke, heat, CO, water, or freeze activation, each sensor on the network does serve as a repeater for that emergency data. This daisy chain effect also happens when a self-test is performed. Let's take a look at how the daisy chain works in the event of a fire. Keep in mind that this animation is slowed way down just to illustrate this process. When a fire is detected by this smoke sensor on the bottom right of my screen, it alarms and immediately broadcasts the emergency activation to reach the other OmniShield units. As soon as that broadcast reaches another sensor, that sensor then alarms and repeats the broadcast in a daisy chain effect, effectively flooding the network until the comlink receives the data and sends out the text message. This all happens very, very quickly. On the other hand, battery and temperature updates for each sensor must communicate directly to the comlink in order to push updates to the app. Each unit has its own internal timing mechanism and will attempt to send these updates once an hour. If the update is missed, it does not try to send it again, it simply tries again at the next hourly interval. So how can I get all the units updating in the app? Understandably, some customers are bound to get hung up on units that aren't updating. In those cases, it's important to reassure them that their units will do what they need to do in the event of an emergency. You can demonstrate this by having them self-test the units and to make sure it still sends them a text message. There are actually 3 options to get those stubborn sensors to update in the app. Different installs might call for different solutions, so we will discuss each of them individually. Let's take a look at a common scenario. Here we have a network where 3 out of the 5 units are sending updates reliably. The other 2 units are failing to update, either due to distance or interference. The smoke sensor in the bottom right has not updated in 3 weeks, and even that update was a partial one that makes the battery appear blank in the app. Being aware of the limitations, knowing your options, and having the knowledge necessary to get that network updating properly is absolutely key to reducing the amount of service calls you will get in the future. Option 1 is to take the existing comm link and relocate it to a more centralized area in the home. To do this, you will need to switch the comm link to Wi-Fi so you're not tethered by the router anymore. When internet providers come out to install cable or fiber to a customer's home, they are typically going to install the connection and router in the most convenient place for the technician. Unfortunately, the most convenient place for the technician is almost always the least effective place in the home to have that router. That's why you see people's routers in their basement or on the far end of the home in a bedroom. Switching the comm link to Wi-Fi gives you the flexibility required to place it in a better suited area. This can mean the difference between some units updating and all the units updating. In summary, this option is the most cost-effective because no additional equipment is required. Just relocate the customer's comm link to be more centrally located in the home or away from potential interference. It also allows you to be untethered from the router that is installed in a poor location. The trade-off is that unless the customer's home is wired with Ethernet all over, you'll need to switch the comm link to Wi-Fi in order to relocate it away from the home's router. And of course, if you have installed an Ethernet-only comm link, switching to Wi-Fi will not be an option. Option 2 is to add an additional comm link to the home. Just add a new comm link to the customer's Wi-Fi and then choose a location that's closer to the units that aren't updating. The secondary comm link does not connect to the existing comm link or units, but it will act as a bridge for those units to get their information out to the server and where it needs to go. So information relayed by the secondary comm link will actually appear in the original comm link's app. In summary, this option is great because it allows you to keep the existing network exactly the same, meaning you keep the original comm link where it is. Install the additional comm link in the general area of the units that aren't updating. Hook it up via Wi-Fi so you can adjust the placement as needed later. The only real downside to this option is the confusion that it could potentially cause. Let's clear up some commonly asked questions about secondary comm links. You don't bind the secondary comm link to the original network or the original comm. It will be a standalone unit. You will need to set up the secondary comm link using the app to register it, add contacts, and bind a sensor. You must bind at least one sensor temporarily to get the comm link out of bind mode. You can unbind the unit and take it with you when you're done with the install. The secondary comm link receives any OmniShield battery and temperature updates within range and relays that information to the appropriate network on the server. The secondary comm link is not responsible for texting alerts. The main or original comm link you had set up will do that for you. The secondary comm link only functions as a repeater to get this information out to the internet. Back to this same scenario again with these units that aren't updating. Option 3 has been a long time coming. In production as we speak, we now have a product specifically designed to solve the problem of units not updating. The booster, as it's called, takes all OmniShield RF data within its range and acts as a repeater, sending that information to the original comm link. But the best part is you don't need to bind it to the existing network, and even more impressive, you don't need to hook it up to the internet at all. You just plug the booster into power somewhere between the comm link and the units that you're having trouble updating. So if it's actually repeating or relaying the data, why is it called a booster? Well, because repeater didn't sound nearly as marketable. But actually, if a unit is on the far side of a house and the RF is barely reaching the booster, when that booster turns around and rebroadcasts that signal at full strength, you are in fact boosting the original data sent from the unit on the far end of the house. So I guess it is a booster. In summary, adding a booster is by far the easiest solution to the problem of units not updating. We have been field testing this for a few months now, and the feedback has been phenomenal. Unfortunately, I couldn't think of any drawbacks to this option other than they are not available to purchase yet, but don't worry, they are coming soon. Let's switch gears now and go back to the basics. How to install a comm link. Let's talk about installing a comm link via Ethernet. This is the simplest and quite honestly the most reliable of connections. To install the comm link, first locate the customer's internet router and assess their current setup. Some setups are super simple, but others may not be. Let's take a look at the two most common setups. Here we have a modem and a router as separate devices. In this example, we have the internet coming into the home through a cable connection. Typically, a cable modem will only have one Ethernet port. This provides the homeowner with a single connection, unless they also have a router. There will be an Ethernet cord connecting the modem and the router. The router takes that single connection provided by the cable modem and creates a local area network that allows all your devices to connect to the internet and with each other. To install the comm link to the router, connect one end of the Ethernet cord to the comm link and the other end plugs into an open Ethernet port on the router. Then plug the comm link into power. Once powered on, the green power icon will begin to blink as it tries to establish a connection with the internet. Once connected, the blue radio icon will begin to blink, indicating the comm link is in bind mode and ready to accept sensors. Next, we have a modem and router combo, a single device that functions as both the modem and the router. Here we again have the internet coming into the home through a cable connection. But unlike the previous setup, this unit is both a modem and a router. These devices are commonly provided by internet service providers or ISPs to their clients for their home internet. To install the comm link to a wireless gateway, connect one end of the Ethernet cord to the comm link and the other end plugs into an open Ethernet port on the gateway. Then plug the comm link into power. So what about other setups? Those two examples cover the majority of residential internet hookups. However, from time to time you'll run across unique setups. A good rule of thumb is to try to locate the modem first. When you find the modem, follow the Ethernet cord coming out of it to see what device is connected next in the chain. And remember, plugging the comm link into something wrong is unlikely to cause problems other than the comm link not connecting. However, unplugging wires you're unsure about what they do can definitely cause problems with the customer's home internet. So use common sense, and if in doubt, ask. So what if the router's ports are all full? In that scenario, you can use what is called an Ethernet switch to add additional ports to their router. Switches are inexpensive and great to have on hand in case your customer's router is full. Let's take a look at adding an Ethernet switch to a full router. Connect the switch by first freeing up an outgoing Ethernet port on the router temporarily. Keep track of the Ethernet cord you unplugged to make room for the switch. We want to make sure we reconnect it for the customer. Plug one end of an Ethernet cord into the open router port. Plug the other end into the first port of the switch. The Ethernet cord you removed from the router can now be plugged back into the new switch. Next, plug in the power to the switch. Now you have 3 additional Ethernet ports connected to the router. Plug the comm link into one of the open ports on the switch to connect it to the internet. So which Ethernet switch should I buy? Any 5-port gigabit Ethernet switch will work. Brands like Netgear, TP-Link, and Linksys can all be found online or at your local store. However, pay attention to the speeds listed on the products. The switches you buy should be gigabit or 10 over 100 over 1000. If you get a switch that only has 10 over 100 listed as the speed, you're doing the customer a huge disservice. Spend the extra few dollars and get a model that supports high-speed internet. If you don't, anything the customer plugs into that switch could be running at 1/10 of the speed they're paying for. What about routers that have no Ethernet ports at all? Well, that's a great segue to the next section, which is how to install a comm link via Wi-Fi. I know a lot of you asked about Wi-Fi installs and how to do them, so I'm going to give you a visual of how it's done. Just keep in mind that I'm using an iPhone during my install, so things can look differently if you're running Android. But the basic principles are the same. Before you begin, you're going to want to make sure you have the homeowner's Wi-Fi name and password. If you wait to the last step to do this, or to even look for this information, the app may time out and cause you problems. I also recommend you use your own device to do the install. It doesn't make sense to struggle with another person's phone configuration during this process. When you're using your own device for installs, it guarantees that you're working with a device that has successfully done a Wi-Fi install previously, and it will boost your confidence by using a device you're familiar with and know how to navigate. I also want to clear up some common misconceptions that seem to trip some people up. When you get to the step where you need to join the Comlink's Wi-Fi, joining the Comlink's broadcasted Wi-Fi is only the first step of connecting it. After it joins the Comlink's Wi-Fi and you see the words "no internet connection" below it, I notice that some people tend to get discouraged there, but you really shouldn't, because the Comlink is not intended to have internet yet. That's the whole reason we connected to it, is to program it. So we have to connect to the Comm's Wi-Fi before we can use our phone to directly program the Comm with the homeowner's Wi-Fi credentials. Here we are on my iPhone, and you can see I've got the 2 apps we're going to need just right here on the screen so we can see them. We need the OmniShield app, and we're going to need our settings app. So I'm going to open up OmniShield version 2 and then click on New Network. And then from here I'll choose Wi-Fi. Next screen it says make sure your comm link is plugged into power and does not have an Ethernet cable connected. Then it says open the settings app on your phone, choose the Wi-Fi network containing the word comm link, and return to the OmniShield app when you're finished. It's important to remember to remove any Ethernet cord you may have plugged into the comm link if you're attempting a Wi-Fi install. The Wi-Fi of the comm link itself will not broadcast if the Ethernet cable is still plugged in. The next thing I want to point out is that every step you need to take inside the OmniShield app to get the comm link paired with Wi-Fi is written out for you. So really the best thing to do is read each and every pop-up dialog. I know you guys get tired of some of the pop-ups that we have, but each one of them has important information that you should read. So on this one, I'm going to read it again. Open the Settings app on your phone, choose the Wi-Fi network containing the word Comlink, and return to the OmniShield app when you're finished. So what this wants you to do is go to the Settings app on your phone itself, and then click the Wi-Fi that is named Comlink with some numbers after it. Those numbers that are after it are the Comlink's serial number on the back of the unit. Once you get connected to the Comlink's Wi-Fi, then you proceed with the next step in the app. So before you hit next on this screen, you have to make sure you go into your settings on your phone and connect to the Comlink. So let's do that now. I'm going to navigate away and go to my settings app, click Wi-Fi, and then from the list I'm going to choose the Comlink 57705, which is the one I have here on my desk. After that connects, it's going to say no internet connection like we discussed in a previous slide. And that's because we haven't programmed it yet. So the next thing that we're looking for after this connects is, you see in the top right of my screen where it's got my battery icon on my phone, it says 5G and it has my cell signal. We are waiting for that 5G icon to turn back into a Wi-Fi symbol. That visually lets us know that the phone has fully connected to the Comlink in this bridge mode of sorts, so we can start programming it. So this can actually take up to 30 to 60 seconds depending on the person's phone. As you see on mine, it just turned into that Wi-Fi symbol, so we're going to continue on to the next step now. I do also want to point out that 5G turning into the Wi-Fi symbol visual indicator is only visible in iPhones when you're doing the install. It's not going to be there on Androids. It's not going to behave the same. So if you're looking for a visual indicator on Android, unfortunately there's not. And that's just something that is due to the phone and its settings. We can't really control that. The best thing I can tell you for Android is once you connect to the Comlink's Wi-Fi and you continue on to the next step, if it gives you an error immediately, just keep retrying until it finally connects, because there is no way to tell when an Android is fully connected to that Comlink that I'm aware of. However, we are working on a brand new version 3 to the app, which should make Wi-Fi installs on both iPhone and Android much simpler. So now we're going to go back to my phone here and continue on with the next step of the install, which is to go back to the OmniShield app and then select Next. Here it'll show a list of the Wi-Fi's available in the area, and we're going to choose GHS, which is the one here at my office, and select password because it is password protected. I'm going to paste my password in here and then hit Next. It'll tell you that you need to disconnect the Comlink and connect to Wi-Fi settings here. You don't necessarily have to do this, but going back to the settings and just making sure you're back on your regular Wi-Fi will help to ensure that you're not still connected to the Comlink. Once you get back to the app, it'll ask you if there is a solid green light or if it's flashing blue and yellow. And in my case, it was successful, so I hit solid green light, and now we are on the sensor screen ready to start pairing sensors. So that's all there is to it. I know the whole process can be cumbersome, but I promise you it does not take that long to learn once you start practicing. What did these blinking lights mean? I plugged the Comlink into power and I hooked it up to the router, and all I get are these blinking yellow and blue lights. Alternating blue and yellow lights indicate the Comlink has no internet connection. First, ensure all cables are securely connected and that the internet is working for other devices. Just because the homeowner's Wi-Fi is working does not necessarily mean their Ethernet ports are working on their router. Also, make sure you're plugged into the proper device on their home internet setup. And finally, here we are at the most important troubleshooting step of all. And if you've ever called me, I know you've heard me ask you this, and you probably get tired of it, but it really is the most important step. And that is, did you turn it off and back on? If you are certain you have plugged the comm link into the correct device and you're getting no connection, power cycle the router. And what does that mean, power cycle? Well, leave the comm link plugged into power and connected with its Ethernet cord, but unplug the power to the router for a full 60 seconds. Then plug the power back into the router. Allow a few minutes for the router to fully initialize, and depending on the unit's age, it could take up to 5 minutes. After the router is back online, check your comm link. If the unit goes to a blue radio light only, then you have connected to the internet and it is ready to bind units. If the unit goes to a solid green power icon, you have successfully connected to the internet, but the comm link is no longer in bind mode. You might have to open it back up if you are still needing to add units. If the unit blinks a green power icon, it is attempting to make a connection to the internet. If the blinking green stops and changes to alternating yellow and blue, the connection was not successful. So when rebooting the router doesn't work, the first thing you're going to want to try is to power cycle the comm link. Unplug the power and plug it back into the unit. Next, you could try checking the connections on both ends, meaning the Ethernet port on the back of the comm link and the Ethernet port on the back of the router. Make sure the cord clicked into place securely as you plug that in. You can also try a different port on the back of the router. It could be that you've just plugged into a port that's gone bad. So just try all the open ports on the router. And finally, you can try a different Ethernet cable. I've seen Ethernet cables go bad brand new. So it can happen. Just carry extras. It's an easy fix. And finally, check the LED indicators on the Ethernet port of the comm link. They should tell you if there's a physical connection detected as well as if data is coming through that port. If a connected comm link has neither of these LEDs lit up, there's either something wrong with the cables or the Ethernet ports on the router have gone bad. Contact the ISP or Internet Service Provider to diagnose. Just make sure you power cycle the router prior to calling the ISP, because that's going to be the first thing they ask you to do. Now we're going to move on to some of the questions you guys asked that didn't really fit into the presentation. So here we go. Why didn't the comm link come back online after a power outage? Well, when the power is restored to a home after an outage, everything receives power all at once. If a comm link powers on and begins trying to connect to the router, there's a possibility the router hasn't fully initialized yet. So if there's nothing for the comm link to connect to, it will begin to blink the alternating blue and yellow to indicate it's offline. Oftentimes this is corrected after the router fully initializes, but sometimes you may need to power cycle the router as discussed earlier. This scenario is not unique to the comm link. That's why the ISPs will always have you reboot their router first when you call in for technical support. Sometimes people get frustrated when they call in because I always ask them if they've rebooted their router. So it only made sense to ask this question: why does rebooting the router help? Well, your router is essentially a computer. Rebooting your router, like any computer, clears its memories, ends all tasks, and reloads the router's operating system, which will fix most issues. Waiting 10 to 30 seconds just ensures that any remaining power stored in the router has a chance to dissipate and the RAM or memory clears. For comm link connectivity issues, rebooting the router forces it to reinitialize the Ethernet ports and detect any new devices that may be plugged in and trying to connect. So I get this next one in quite a bit, and it's usually not in the form of a question. It's usually someone telling me that they couldn't get the comm link to connect, so they swapped it out for another comm link, and that one connected. So that must have been the fix, right? It was a bad comm link. No, the fact is that the comm links are actually pretty simple devices, and the chances of your connectivity problems being directly related to the comm link's hardware is very, very slim. In fact, most of the returns we receive for defective comm links are actually completely unwarranted. The actual reason for comm links not connecting is almost always directly related to something going on with the customer's internet setup. Issues with their routers having bad or disabled Ethernet ports, firewalls or parental controls blocking our server, or even bad Ethernet cables are much more likely to be to blame. If that's true, then why did a different comm link fix the issue at my customer's house? Well, coincidence, most likely. Unplugging the comm link you were having connectivity problems with and plugging in a brand new comm link is really just a more expensive and time-consuming way of rebooting. The same results could have probably been achieved by simply unplugging and plugging back in the original comm link. That's not to say malfunctioning comms are impossible to come by, but the point is you should not be so quick to label the products you carry as being faulty. The reason why IT professionals always ask you to reboot first is because it is the most common solution to issues with electronic devices. As I was binding sensors to the comm, they stopped popping up in the app. This is something I've been getting asked more frequently. The root cause of this has not been fully identified yet, but we do believe it is due to the server's load at the time of which you were doing your install. And the fix, yeah, you guessed it, reboot the comm link. It will reconnect to the server, and any units bound to the comm link after that reboot should start popping up in the app again. While we may not know the exact cause of the issue, we are confident it will resolve itself when we migrate to the new server environment that we are currently working on. I was self-testing sensors at the end of my install, and the customer stopped receiving the text messages. This has been reported as happening occasionally during installs and is directly related to the issue mentioned in the last question. The fix is also the same: reboot the comm link. Why does the identify button not always work in the app? The identify feature in the app is only available while the comm link is in bind mode and units have been bound. It is a feature to assist you if you accidentally mix up the units while you're installing. Pressing the identify button in the sensor details of the app will send a signal to request that unit to beep and light up. This feature is not intended for you to use on each and every sensor. The more you press the identify button, the more you're introducing unnecessary RF noise inside the home. This can cause features that rely on RF to be delayed or ultimately fail until the level of RF noise in the home subsides. So the point is, only use the identify button to do what it was intended for, and that is to identify a sensor you may have misplaced. Believe it or not, I get this next question more often than you would think. How do you add sensors to an existing comm link? And for this one, I'm just going to read straight from the manual because it does tell you specifically how to do this in the manual. Adding a sensor to the network. To add a device to an existing OmniShield network, perform the following steps. Step 1. Press and hold the button on the comm link. The fire icon will flash red and the horn will sound. Continue holding. Step 2. The warning icon will begin to flash yellow. Count the yellow flashes. Step 3. Release the button on the 5th flash. The blue radio icon will begin to flash. This signals that the comm link is ready to add sensors. Step 4. Add the new sensors in the same manner as described on page 11. For those of you that don't have a manual, page 11 just tells you how to turn a unit on. So you slide that switch on the back of your smoke to the activate position and it will automatically go into bind mode. Step 5. The new device will appear on the Sensors tab of the OmniShield app. But how do you remove sensors from the comm link? Well, luckily that's in the manual too, even on the same page. Removing a sensor from the network. In case a device must be removed from your OmniShield network, the network data must be removed from the unit's memory. Repeat steps 1 and 2 listed above on the device to be removed from the network. And when it says steps 1 and 2, it's referring to push the button down, hold it, and then step 3, release the button on the 10th yellow flash. The alarm will chirp twice and all 4 icons will strobe briefly on. All network data has been erased from the sensor. Now you can delete this from the app. No one really asked this next question, but I just thought it should be said. Do not 10 count the comm link. 10 counting the comm link will erase its binding information, rendering the network useless in regards to app information or text messages. Just don't do it. had someone ask me, what is a 15 count used for? And that's a good question because it's not talked about very often, except in the manual. A 15 count is performed when you need to completely wipe out any previous Wi-Fi connections the Comlink had stored. So if you had the customer Comlink on Wi-Fi and they got a new Wi-Fi with a new password, then you'd want to 15 count that Comlink so you can then program it with the new Wi-Fi. Should we carry surge protectors on installs? Absolutely. As a fire safety advocate, doesn't it make sense to protect their Comlink and router against lightning strikes, electrical storms, and other sources of voltage spikes? Fire safety aside, you're inevitably going to run across scenarios where they simply don't have an outlet available for you to plug the Comlink into. So being prepared will save you tons of time in the long run. And you can never have too many surge protectors, Ethernet switches, or Ethernet cords on hand in your install inventory. Lastly, I want to say thank you to each and every one of you that tuned in today to watch this training live. We will have this posted on the Global Peak Training site for future reference. And I will just leave you with this final question. Did you try turning it off and back on again?